Hey guys, welcome to the session by Intellipaat. And in today's session, we are going to discuss about one of the most commonly used machine learning algorithms, logistic regression. So let's have a quick glance at the agenda. We'll start off with a quick look back at the linear regression algorithm, and then we'll comprehensively understand the concept of logistic regression with the spam email classifier example. And then we'll understand what is the confusion matrix, and finally we'll implement a demo with the logistic regression algorithm.
Let me just give you a quick recap at the linear regression concept as we would be needing them in logistic regression. So let's start off linear regression recap with this example. So this is Lauren. She's looking for a property to buy, but she's confused how to start. So she goes to one of her friend, Josh, and asks him if he could help her to find a property with bigger garden area for X bucks. Our guy, Josh on the right, agrees to help her to find a property, but he himself doesn't know how. So what he do, he goes to another friend of him, explains him the whole situation, and asks him if he can do anything about it. He immediately says yes and start doing some calculations. Then he says to Josh that spending X bucks can get her a property of area Y. Now Josh is confused and asks him how did he find out. The friend goes like, simple linear regression. Now let's see how exactly he used simple linear regression to solve his issue. So here are our dependent variable and independent variable. Property size being the dependent variable and money being the independent variable. What this guy want to do? He want to find out a relation between the property size and money. So it's like if you want a house of bigger area or bigger property size, then you have to spend more money. So both of them are directly proportional, right? So in this case, we'll get a positive linear regression line, right? That is spending more money will get her a bigger property, okay? In other case, but again, our next scenario is she wants a bigger garden area, right? So imagine the scenario keeping the property area constant. The house area is inversely proportional to the garden area. It's like if you want to increase the garden area, so you have to reduce the house area. So take it like this. Suppose you have already fixed the property and you want to construct a house with a garden in it. But now your demand is you want to have a bigger garden area. So if the size of the property is fixed and if you increase the size of the garden, then obviously you have to reduce the size of your house, right? So in this case, if you try to plot a regression line, you'd get a negative regression line, right? Bigger garden area means smaller house, right? Now let's take an example to see how exactly did he predict the value of the house. So in order to find the regression line, what he did, he took the historical data of property area sold in the particular price, okay, and he plotted it on the graph. So this was the plotted point of property area sold in past for a particular price, okay. Now what he did, he drew a regression line. Now to find out what property area she can buy with X bucks, he plots X on the independent variable scale and project it to the regression line. And then against that point, there he has the area Y. This is the area Y. So this is how he predicted Lauren can buy Y area of property in X bucks. Alright. Now let's see what he can and what he cannot say from this. So he can say that if Lauren spends X amount of money, she can buy a property area of Y. But what he cannot say is, will the property would have a good neighborhood or not? Or will the location be noiseless suburb or a bustling city? Right, so these are the questions which even he cannot answer using this graph. So the questions like, will the property will have a good neighborhood? Or will it rain tomorrow or not? Or is this mail a spam or not? All these kind of problems fall under a particular category known as classification problems in machine learning. Now with linear regression algorithm, we could not answer these problems. So that is where logistic regression comes into picture. Now let us see where this logistic regression algorithm that we just talked about lies in the machine learning algorithm tree. So in machine learning, we use two traditional learning techniques to build a predictive model. Supervised learning and unsupervised learning. Again, look at the supervised learning. There are two categories, regression and classification, right? In regression, we have linear regression, and in classification, we have logistic regression and SVM. So our today's topic of discussion is logistic regression, which comes under the category of classification. Okay. So now that we have got a little bit idea about logistic regression, let's go a little bit deeper and discuss about what exactly is logistic regression and why do we use it. So what is logistic regression? Well, logistic regression is a statistical classification model that deals with categorical dependent variable. Again, you must be wondering, what are these categorical dependent variable? Well, these are some of the discrete variables that have two or more categories without having any kind of natural order. For example, temperature, area, or gender. Okay. So you can say that logistic regression is generally used where the dependent variable is binary, or where the dependent variable is binary. That is, only two outcomes are possible, either yes, no, true, false, 1, 0, etc. Right. And also remember a fact that you can use both continuous and discrete input data with logistic regression. So before moving ahead, let's look at the graph. See, there are two variables. One is independent and other is dependent. Can you figure out which one is dependent and which one is independent? So before moving ahead, let's take a look at this graph. So over here, we have two different variables, hours studying and probability of passing exam. Can you figure out which one of them is dependent and which one of them is independent? So if you have guessed that hours of studying is your independent variable and probability of passing the exam is dependent variable, then I'd say that you are 100% correct. So now that you know what exactly is logistic regression, let's move ahead and see why do we use logistic regression. Well, logistic regression can be used as a tool for applied statistics and discrete data analysis. Why? Because it gets the output in the form of probabilities, which help us to easily classify the given data. Okay, so this is why we are using logistic regression. So now that we have successfully established the basic of logistic regression by understanding what and why of it, let's go ahead and see how logistic regression can be applied for classifying data with the help of an example. So here we are using an example of spam email classifier. We need to build a predictive model that would classify whether a mail is spam or not. So let's look at the approach that we are going to take while building this model. First, we'll try to understand the variable that on the basis of which we are classifying the mail. Next, we'll plot the label data. Once we are done with plotting the label data, we'll draw the regression curve. And finally, we'll try to find out the best fitted curve using maximum likelihood estimator. Alright? So let's get started. So step 1 is defining the variable. So let's start off by understanding what is independent variable in our case. So in our case, the independent variable is count of spam words. Well, here are some examples of commonly used spam words. Word like buy, get paid, guarantee, winner, unlimited, etc. Okay, so these are the kind of words which when found in the mail is treated as spam. If the number of these kinds of words are more in a mail, then that mail would definitely be a spam mail. Okay, just for a better representation, let me put them in a bag of spam words. Let's put the bag. So there's a bag of spam words. Let's put all the words in them one by one. Buy, get paid, guarantee, winner, and unlimited. Okay. Now, what about our dependent variable? Well, our dependent variable is going to be the probability of mail being a spam. If the probability is 1, that means the mail is spam. If it's 0, it means it's not a spam mail. Well, in general, the mail with less number of words from the list of spam words will be treated as a spam mail. With 5 or more spam words in a mail would be treated as a spam mail. But there can be cases where you might find mails with less spam words being spam. Also, you might find cases where mails with more number of spam words is not a spam mail. So here our aim is to build a predictive model to classify the mail with minimum error. Okay, let's see what is our next step. So our next step is plotting the label data. Let's say this is a set of data that we'll be using to build the model. This is a very small data set, but just remember that whenever you are using logistic regression, make sure that you are using a large amount of data. Logistic regression works pretty well with large amount of data. It doesn't work that good with small amount of data. Okay. Here, just for the purpose of understanding, we are using small data set. Alright, so we have two variables, number of spam words and the probability of mail being spam against each mail. Okay. Next, as a step 3, we'll draw the regression line. So next what we'll do, we'll plot our data set on x-axis and y-axis with independent variable on the x-axis and dependent variable on the y-axis. So number of spam words in a mail is an independent variable, right? And the probability of that particular mail being a spam or not a spam is a dependent variable. It depends on the number of spam words in a mail, right? So let's plot these words one by one. So first we have is one word and the probability of this mail being a spam is 0. So it will be plotted up here. So next we have is 5 spam words in a mail and the probability of that mail being a spam is 1. So it will be plotted somewhere here. Next is 3 spam word is a spam mail. So it will be plotted again here. 2 words, it's not a spam mail. So I'll be plotting up here. 7 words, again a spam mail up here. 4 words, not a spam mail here. 9 words, it's a spam. 8 spam words, again, it's not a spam. So once we are done with the plotting, this is how our plotted data would look like. Now let's say that we have a new mail and now we want to figure out whether it's a spam or not. So before moving ahead, let me just tell you, in real world scenario to perform logistic regression, you need a large amount of data set. And also you might find many cases where a spam mail might contain only 2 words, where a spam mail might contain only 2 spam words. Or also it might be possible that you get a mail where you are having more than 5 spam words and even in that case, your mail is not a spam. Okay, so here we are building a predictive model with primary aim to reduce the error. Okay, now let's say we have a new mail up here. Now we need to figure out whether this mail is spam or not. But how do we do that? Well, first of all, we need to plot a regression curve which would fit the best. And that curve would be our logistic regression curve. But now the question comes, how to find out which is the best regression curve? Okay, well, this will contain 3 steps. Well, the first step is to convert the y-axis from the scale of probability confined between 0 and 1 to a scale of log odds. Then drawing a random regression line out of the data that we already have. Then with the help of sigmoid function, we'll convert the log odds to the probability of mail being spam. We'll plot each mail on the basis of their new probability values. And this will form our regression curve. Then finally from this plot, we'll find out the log likelihood values of each mail. Now from this plot, we'll find out the log likelihood values of each mail. The individual likelihood. At last, we'll find the log of likelihood. That would be our log likelihood of the regression curve. Now the question comes, what are these terms such as log odds or log likelihood means? So before moving ahead, let's discuss that. So what does log of odds mean? Let us explore this with the help of an example. So before we proceed any further, let me just clarify you one thing. This probability and odd, these are not the same thing. Let me explain you this with an example. Suppose this guy, he goes to fishing 5 times a week. So out of 5 times, he catches a fish 2 times and he failed to catch 3 times. Okay. So now in this case, what is the probability and odd for getting a fish for dinner? So let's first calculate probability. So probability is chances for divided by total chances. So chances for catching a fish. So what is the probability of catching a fish? That is how many times he caught a fish. That is 2 divided by total chance he had to catch the fish. So that was 5, right? So here probability of getting a fish for the dinner is 2 by 5. Okay. Next comes the odd. Chances for divided by chances against. That is the ratio of how many times he caught the fish divided by how many times he failed to catch a fish. Okay, so he caught the fish for 2 times and he failed in catching the fish for 3 times. So the odd for getting a fish for dinner is 2 by 3. Okay, so now that we know odds, now let's see what log of odds and log odd ratio are. Are they same? Let's find out. For your information, log odds is also called as logit function. Okay. So in our previous example where the fisherman was catching a fish, let's add another factor to his fishing. Let's add a factor as weather. So then we can recreate the entire scenario as he was successful 2 times on a rainy day. But on a sunny day, he was successful for 3 times. Now the odds of catching fish on a sunny day is how much? It's 2 by 3, right? and the odds of catching on a rainy day is 3 by 2, right? As it's already mentioned that on a sunny day, he catches 3 times. So he is successful for 3 times and he failed for 2 times. So let's see, he was successful 3 times on a rainy day and 2 times on a sunny day. So odds for catching a fish on a sunny day is 2 by 3. That is, he's successful 2 times on a sunny day and he failed for 3 times in a week. So odd for catching fish on a sunny day is 2 by 3. Similarly, odd for catching fish on a rainy day is 3 by 2. And now log of odds of catching a fish on a sunny day is just log value of 2 by 3. And similarly, log of odds of rainy day is log of 3 by 2. Now, log of odds ratio is nothing but the log of odds on a rainy day divided by odds on a sunny day. Okay. Next is log of odds ratio. So log odds ratio is nothing but the ratio of log of the odds on a sunny day to log of the odds on a rainy day. That is log of 2 by 3 by 3 by 2, which is nothing but log of 0.44. So here we can say that odds and odd ratio are both different things. Now let us go back to this step. So now that we have understanding of log odds, so we are ready to perform this step. Okay. So let's see how we converted the 0, 1 axis to minus infinity to plus infinity axis. So here we'll be converting the probability scale to scale of log odds. Okay. So for the log odds, we have a formula as log of probability of spam divided by 1 minus probability of spam. So here the probability of a mail being a spam is 1. Okay. So we get the value of log odds as log of 1 divided by 1 minus 1. That is log of 1 by 0. It's positive infinity. How we got that? So log of 1 by 0 is nothing but log of 1 minus log of 0. And log of 0 up here is minus infinity. So minus of minus infinity is what? Plus infinity. How log of 0 up here is minus infinity? Let's see. So in general logarithm, so we have log 0 with base b equals c. So if you convert it into exponential form, we get 0 equal b to the power c. Right. So if the value of b is less than 1, so the value of c has to be extremely small or closer to minus infinity for this equation to be true. Okay. And we'll get a positive infinity in the case where b is greater than 1 or our base is greater than 1. Okay. So coming back up here. So here log of 1 by 0 is nothing but log of 1 minus log of 0. And we got the result as positive infinity. As log of 0 up here is minus of infinity. And minus of minus infinity is what? Plus infinity. How we got the value of plus infinity? Let's see. So log 0 with base b equals c. If we convert this into exponential form, we get something like this. 0 equal b to the power c. Right. So for the equation 1 to be true, if the value of b or the base is less than 1, then in that case, the value of c will be positive infinity. Okay. For example, 0.1 to the power 1000 would be smaller than 0.1 to the power 100, right? So more the value of c up here, more closer will the number get to 0, right? And in next case, if the value of b is greater than 1, so for this we have to make the value of c closest to minus infinity. Why? For example, we have 10 to the power minus 1, okay? Or 10 to the power minus 10, which is more smaller. 10 to the power minus 10, right? So which is much smaller or closer to 0? 10 to the power minus 10, right? So that's why we have to keep the value of c as less as we can. So here, if the value of b is greater than 1, the value of c would have to be close to minus infinity in order to make the equation true. So in this case, log of 1 by 0, by default we have base as 10. Okay, so that's why we took the value of c as minus infinity. So minus and minus of infinity is plus of infinity. So that's why we got the plus infinity up here. I hope this thing is clear to you. How we got the value of log odds as plus infinity. So we'll plot this up as plus infinity log odds. Now next, let's find the log odds of non-spam mail. So here we have the formula as log of probability of a mail not being a spam divided by 1 minus probability of mail not being a spam. So log of 0 divided by 1 minus 0. So we have log of 0 by 1, which is log 0 minus log 1, which tends to minus infinity. Okay, similar concept. Now we have our data up here. So first we'll assume one regression line. So now we have our data up here. So first we'll assume one regression line. Then we'll project our data onto the regression line. Okay. Now let's just go back to the step where with the help of sigmoid function we'll convert the log odds to the probability of mail being spam. Okay. But what does this sigmoid function mean? So sigmoid function is the standard logistic function. The logistic function is defined as L multiplied by e to the power k times of k minus k dot upon 1 plus e to the power k times of x minus x naught. So here L is the curve's maximum value, k is the steepness of the curve, x naught minus x is the value of sigmoid point. Okay. So here the sigmoid function e to the power x divided by 1 plus e to the power x, here k equal 1 and x naught equals 0 and L equal 1. So this mathematical sigmoid function form S-shaped curve which is confined between 0 and 1. Let's try to understand how logistic function works with the help of an example. So let's say we have a set of unspecified data and on these data we need to apply a sigmoid function. So let's see what a sigmoid function can do by visualizing this graph. So let's say we have a unspecified data and on these data we need to apply a sigmoid function. So plot this data and find out the respective y for these points. Okay, so what a sigmoid function is doing, it can be visualized from this graph, right? So you are giving some values on your x-axis and using sigmoid function you can predict its probability on the y-axis, right? So this is the reason why sigmoid function is very useful while solving the classification problem. It takes any real valued number and maps onto a value between 0 and 1. Okay. Well, now that we have an idea of how sigmoid function works, let us move ahead with our spam email classifier. So we are ready to perform this step. That is converting the log odds graph into a sigmoid function graph. Now we have to find out the best MLE. Okay. Best maximum likelihood estimator. So we are going to replace the log odd value of each mail to get the probability of each mail being a spam. So we have the formula up here, probability equal e to the power log odds divided by 1 plus e to the power log odds. So one by one we'll place the log odds of each mail into this formula and calculate the probability for each mail. Okay. For example, I have this mail which after projecting into the regression line gives us log odd value of minus of 3.2. Okay. So what we'll do up here, we'll calculate the probability using the value of minus 3.2. We'll place the value minus 3.2 in our formula, e to the power log of minus of 3.2 divided by 1 plus e to the power log of minus of 3.2. So from here, we'll get the probability as 0.03. So plot it accordingly onto the new graph between probability of mail being spam versus spam word count. So on the basis of probability, our mail would lie somewhere near to 0. So according to the prediction, this mail is not a spam mail. Again, for another mail which is projecting on a regression line, this gives us a log odd value of 5.6. So when we put the value of 5.6 in the formula, we get the probability as 0.99. So the probability of this mail being a spam is 0.99. So again, we put this into this graph. Similarly, one by one we'll calculate for each one of them. For this mail, after projecting onto the regression line, we get the log odds value as minus of 4.5. So minus of 4.5 and put into the formula, we get the probability as 0.01. So the prediction of this mail is not a spam mail, which is same as actual, right? So again, we plot this mail onto a graph, alright? So similarly, you can repeat this step for the rest of the email as well. And finally, we got the S curve up here. So this is our regression curve. But you must be wondering, is this the best fitted curve? Or how do we find out whether it's best or not? Well, this is when the concept of maximum likelihood comes into picture. So now that we have regression curve, let's find out the likelihood of this curve. So first find out the individual likelihood of each mail. Again, you must be thinking, how do we get the likelihood value? Well, likelihood of each mail is nothing but the probability value of each mail being spam. So likelihood of first mail being spam is 0.01. Likelihood of second mail being spam, again 0.01. Similarly, third 0.03, fourth 0.05, and so on till 8th mail being 0.99. Okay. So once you get the individual likelihood of each mail, multiply them to find out the likelihood of the entire curve. Okay. Then calculate the log of likelihood. For calculating the log of likelihood, you can just take the log of the previous result. Okay, you can just take the log of previous multiplied result. Here we are adding all the logs because log of a multiplied by b equal log of a plus log of b. Okay, so we got the value of log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. So we got the log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. Again we calculate the individual log likelihood of each male. For this one, let's say we got log likelihood which is shown on your screen. So final value we got up as minus of 0.207. So we got the value as minus of 0.207. So now if we compare the log likelihood values for these two regression lines, we'll see that line A has bigger value of log likelihood than line B, right? As line A has log likelihood value of minus of 0.084. So the log likelihood value for line A is minus of 0.084, whereas for line B is minus of 0.207. So minus of 0.084 is bigger than 0.207, right? So therefore we can say that line A has better likelihood value than line B. Now again we'll rotate the line. We'll keep on rotating the line until we get the maximum value of log likelihood. And then finally we'll choose a line which is having the maximum log likelihood, and that line would be the best fitted regression line. So I hope the concept of logistic regression is clear to you guys. So for now, this was all about the theoretical and mathematical concept of logistic regression. So the confusion matrix shows the ways in which your classification model is confused when it makes predictions. It is basically a summary of prediction result on a classification problem. The main key to a confusion matrix is summarize the count value of correct and incorrect prediction. So the image shown on your screen represents a confusion matrix. Let's see what exactly does it mean. But before that, let me just tell you how to create a confusion matrix. This would make things more clear for you. So let's see how. So for creating a confusion matrix, you would be needing a test dataset or a validation dataset with expected outcome values. Then make a prediction for each row in your test dataset. Then from the expected outcome and prediction, count the number of correct prediction for each class and the number of incorrect prediction for each class, organized by that class that was predicted. Okay, let's see what exactly does it mean. So here's an example. We have some expected output and a predicted output for that. So from here you can see that all the red color results are the incorrect predicted values and the green ones are the correct ones. So in total we have 7 correct prediction out of 10. Okay, so from here you can say that the accuracy of your model is 70%. Now here men classified as men are 3, 1, 2 and 3, and women classified as women are 4, 1, 2, 3 and 4. And now men classified as women, men as women 1 and men as women 2. Okay, so 2, and women classified as men 1. Now if you create a confusion matrix out of it, you'll get something like this. Men classified as men 3, men classified as women 1, women classified as men 2 and women classified as women is 4. So from here you can say that total actual men 3 plus 2 is 5. Total actual women 1 plus 4, again 5. And total correct values, men classified as men and women classified as women, that is 3 plus 4, it's 7. So from here you can say that there are more errors while predicting men as women rather than predicting women as men. Okay, so this was about how you can calculate a confusion matrix. Now let's come back and see how to interpret a given confusion matrix. This is the sample of a confusion matrix. So here we have created a confusion matrix for a fire alarm. So this represents an actual alarm, this represents no actual alarm. Here predicted fire positive and here predicted fire as negative. So if the alarm goes on in case of fire, so it's a true positive event. The alarm goes on and there is no fire, so it's a false negative event. There is no alarm in case of fire, so it's a false negative event. And there is no alarm and there is no fire, then that means it's a true negative event. Okay, so let me just explain you this example. This should make things more clear to you. So actual alarm and predicted fire. So total true positive events we have 40 and total false negative event we have 10. So from here you can say that total number of times the alarm rang was 40 plus 10, that is 50. Okay, here we have false positive event as 5 and true negative event as 95. So the total number of times the alarm did not ring was 5 plus 95, that is 100. And this one is the predicted fire or not. So true positive plus false positive, that is 40 plus 5. How many times the machine positively predicted the fire? So that is 40 plus 5, 45. And how many times the machine was not able to predict the fire? That is 10 plus 95, that is 105. And total number of events, that is 50 plus 100 or 45 plus 105 is 150. So we have mentioned n equal 150 up here. That is total number of events. Okay, so this is how you interpret a confusion matrix. So let's move ahead. So now let me just show you in my Jupyter notebook how you can create a confusion matrix. Let me just open my Jupyter notebook. So this is my Jupyter notebook, and what we are gonna do is create a confusion matrix in Python. So the very first thing that I'll be doing up here is importing the required libraries. So from sklearn.metrics, so I'll be importing confusion matrix. Next, let's create some expected value. Let's say expected equal. So let's add some values in it like 1, 1, 0, 1, 0, 0, 1, 0, 0 and 0. Now this is my expected value. Now let's create some predicted values for that. So predicted equals, first it's predicting correct. Next let's say 0, 0, 1, 0, 0, 1, 0, 1. So this is a predicted value. Now let's calculate the confusion matrix. So let's say results equal confusion underscore matrix. Inside this we'll pass our expected and predicted value. Expected comma predicted and print the result. That's it. Let's execute it. So here you got the result as 4-2 and 1-3. So what does it mean? So first we have is 4. So 0 predicted as 0 is 4 times. 1, 2, 3 and 4. So 0 predicted as 1 is 2 times. 0 predicted as 1, 1. 0 predicted as 1, 2. Okay. Next is 1 predicted as 0. So 1 predicted as 0 is just once here. Okay. And next is 1 predicted as 1, that is 3 times. 1 predicted as 1, 1, 2 and 3. So this is a confusion matrix. And what we can say from here, so total number of correct prediction made by machine is 4 plus 3, that is 0 classified as 0 and 1 classified as 1. Okay. And total number of incorrect prediction is 2 plus 1, that is 3. So we have 7 correct prediction and 3 incorrect prediction. Okay. And the total number of times the machine predicted the value to be 0 is 4 plus 2, that is 6 times. And total number of times the machine predicted the value to be as 1 was 4 times. Okay. So from here we can say that our machine predicts the result 7 times correct and 3 times wrong. So the accuracy of our machine is 70%. So this was all about how you can create a confusion matrix in Python.
A demo with logistic regression with the help of scikit-learn package. And we're going to build this logistic regression algorithm on top of the heart disease dataset. So let's quickly go to Jupyter Notebook and start with a demo, right? So this is Jupyter Notebook, guys. And our first task would be to load up the heart disease dataset. And for that purpose, we would have to import the pandas package. So I'll just type in import pandas as pd, and I'll use this read underscore CSV method from the pandas package. So I'll type in pd.readcsv and I'll pass in the name of the dataset, which is basically heart.csv. And I'll store this in this dataset object. Now let me have a glance at the first few records of this dataset. So this is our dataset which comprises of all of these columns. And we're going to build the logistic regression algorithm on top of this column over here, which is basically target. So target would be our dependent variable and the rest of the columns would be the independent variables. Right. And this target basically means that, so you have 1 and 0 values over here. The 1 value means that the person or the patient has the heart disease, and 0 basically means that the patient does not have heart disease. Right. Now let me also have a glance at the shape of this dataset. So I'll just type in print dataset.shape, and this gives me a value of 303 and 13. So 303 means that there are 303 records in this dataset and 13 columns. Now let me actually have a glance at the value counts of this target column. So this value counts basically tells me the frequency of these two values. So I have these two values in this column, which is basically 1 and 0. So there are 165 records where the value is 1, and there are 138 records where the value is 0. So this basically means that in this data set there are 165 patients who actually have the heart disease and 138 patients who do not have the heart disease. Now I'll go ahead and actually visualize this. So I'll load up the matplotlib package and seaborn packages, and I will pass in this target column onto the x-axis, and the data is our data set, which is basically this heart disease data set. And what I'm doing is basically building a histogram, and I'll plot this up over here. Right. So this is the bar plot for the value of 0, and this is the bar plot for the value of 1. And this basically tells us the same thing. So 165 is the value of the number of patients who actually have the heart disease. So this basically is for all of those patients who do not have the heart disease. Alright. Now let me go ahead and divide the data set into features and label sets. So I'm storing all of the features into this X object. So all of these 12 columns would be my features, and this target column would be my label or would be my dependent variable. Alright. And this is how I'm going to divide the data set. So I'm going to extract all of the columns except the last column and store it in this X object. And similarly, I'll only take the last column and store it in this Y object. Alright. Now let me have a glance at these individual independent variable and target variable. So x.head gives me all of the independent variables, and y.head gives me the target. Right. So now that we have our independent variables and the dependent variable, let me go ahead and divide this dataset into training and testing set. And for that purpose, I'd have to load up the train test split method from sklearn.model selection, and over here I'm setting the test size to be equal to 0.2. So this means that 20% of the records are in the test set and the rest 80% records are in the training set. Alright, I'll click on run again. Now we have divided the data set into training and testing sets. Now finally it's time to build the model, and for that purpose I'll be importing Logistic Regression from sklearn.linear model. And I'm going to create an instance of this. So I'll just use this method Logistic Regression, and I'll name that instance to be log model. And I'm going to fit this model on top of the train set. So I'm basically passing x train and y train as the parameters. Right, I'll click on run. Right, so we have successfully built the model on top of the train set. Now we're going to go ahead and predict the values on top of the test set. So I'll type in log model.predict, and I'll pass in x test as the parameter, and I'll store the result in ypred. So we have also predicted the values. Now it's time to calculate the accuracy. So I will type log model.score, and I'll pass in x test and y test. So I want to calculate the accuracy for the prediction on top of the test set. Right. So the accuracy comes out to be 73%, which is actually not that bad. And let me actually also build the confusion matrix. So confusion matrix would give me a table of values which actually comprises of the correctly predicted values and misclassified values. So I'd have to import confusion matrix from sklearn.metrics, and again I'll just pass in ytest and ypred as the parameters inside this function, and I'll print this out. Right. So this left diagonal which you see, this left diagonal actually represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. And if you want to get the accuracy, all you have to do is add up 20 plus 25 and divide it with all of the values, and you'll get the same accuracy. So let me actually add up a new cell over here and calculate the accuracy from this confusion matrix. So I have to divide this left diagonal with all of the values. So that would be 20 plus 25 divided by 20 plus 25 plus 10 plus 6. And this gives me a value of 73.77, which is the same as I got over here. So the accuracy is 73%, right? So we have built the confusion matrix. Now I'll also go ahead and build the ROC curve. So the ROC curve, it sort of gives me the right trade-off between the true positive rate and the false positive rate. So let me go ahead and plot this. And this is what we get over here. So on the y-axis, we have the true positive rate, and on the x-axis, we have the false positive rate. And basically, you can understand this plot this way. So the closer this curve is to this top right corner over here, the better the model. That is, this curve needs to cover greater area. And this, what you see, red line, so this basically represents a classifier which would give you around 50% accuracy, and your model would be as better as it is far away from this red line. That is, this blue line has to be towards the top left corner, right? And this is how we can implement logistic regression model with the help of sklearn. So guys, this brings us to the end of the session, and do subscribe to Intellipaat's YouTube channel for more such informative content.